The carbon cycle is a natural self-regulating process, and people think of it like the earth breathing. Carbon in the atmosphere is taken up by plants through the process of photosynthesis. Plants put that carbon into their biomass, or they put it into the soil as root exudates. Eventually, their biomass falls to the soil and is gradually decomposed by microbes in the soil. That's released back into the atmosphere as CO2. My research is sort of the study of root exudates, which are small carbon compounds that are released from living plant roots into the soil. And I study how much carbon comes out through the roots as these root exudate compounds and how that's changing in response to climate change and affecting soil carbon formation and loss. So the fundamental research method is measuring root exudates. One phase of my dissertation was taking a bunch of these measurements and trying to estimate exactly how much root exudate carbon plants are releasing per year. And we actually estimated that it's a significant carbon flux, so it's about 10 to 20 petagrams of carbon per year for a frame of reference. That 10 petagrams per year is how much carbon emissions we burn every year as fossil fuels. So it's a large carbon flux. The next phase of my research is understanding how that responds to climate change. So to do that, I went out to a bunch of elevated CO2 and warming experiments in different places around the country and measured root exudation in response to these treatments. The third step was sort of figuring out how does that impact soil carbon. And to do that, I would actually prepare artificial root exudate solutions in the lab, and I would inject these exudates through the artificial root into little pots of soil. And what we found is that the amount of root exudates that the plants put into the soil increased drastically as we went up in temperature. So one of the findings of my research is that the amount of root exudates seems to increase quite a bit in response to warming, and actually increases in the root exudation rate we showed in the lab result in more soil carbon loss than soil carbon formation. So actually, at low rates of root exudation, on balance, root exudates form soil carbon. But as you increase the rate of root exudation, the exudates actually serve as an energy source for microbes in the soil, and that causes microbes to respire or breathe out more CO2 into the atmosphere, and so that actually results in a soil carbon loss. This complicates tree planting as a climate change solution, right? Because yes, trees do store carbon in their biomass, but they're also releasing these root exudates into the soil, which could induce soil carbon losses. And so that's why I say the best solution to climate change is to convert to a renewable energy grid and electric vehicle use. And I think we have to alter our emissions at the source. And I do not believe that nature-based climate solutions alone will be able to compensate for the amounts of CO2 that we're emitting.